Now we're going to look at working with right triangles still and using trigonometry, but we want to see how we can figure out the angles in the right triangle. And furthermore, if it's a right triangle, we know one of the angles is 90. So when we say solve for an angle, we're specifically talking about acute angles. These angles will be less than 90 for sure. And this use of inverse trig functions is pretty simple because we know that we're dealing with acute angles. We'll see later on that the inverse trig functions are actually a bit more complex if you are outside the realm of acute angles, okay? But we're good for right now. So the first thing I want to talk about is you're going to need a calculator, at least a scientific calculator. So you want to see buttons on your calculator that are sine, cosine, tangent, right? So you want those buttons on your calculator. And then what you're looking for inverse trig functions is probably above it, not actually on the button, or maybe it is on the button, but somewhere around these buttons you'll see something like sine with a -1 superscript, and the same for the other two as well. So this is like maybe on the surface of the calculator. And so these are called the inverse trig functions. Sine inverse, cosine inverse, tan inverse. Now, real quick as far as notation, sine inverse could also be called arc, arc, A-R-C, sine. And cosine inverse could be called arc, cosine. And tan inverse could be called arc, tan. And some people like these, if they're talking about, I take an angle approach, some people take an arc approach. So angles and arcs are very closely related. Arc lengths, okay, are very closely related to angles. Also, these guys are easier to type if you're using a keyboard, okay? But nonetheless, they're called inverse. Now, so you'll need your calculator button, and if you want, well, we'll talk about mode in a second, but let's recall inverse functions, right? So if we talk about regular function notation, if f of x equals y, very often we think about f of x as being a y value, okay? Then what does that tell us about the inverse of that? Then the inverse says that x now is going to be the output and y is going to be the input to the inverse function. So when you inverse, the input and output switch places, okay? Now, another thing I want to mention is that these inverse trig functions, so for example, sine inverse is how we read that, is not the same thing as sine to the -1st power. The -1 is a superscript. It's just for notation. It's not an exponent. It does not mean that you take 1 and divide by the sign. It's not reciprocal. Okay? So don't get those confused. So 1 over sine is the same thing as cosecant. Okay? So sine inverse is not the same thing as cosecant. Don't get those confused. All right? Okay, so here we go. This is what we're going to do. We're going to run through some examples. I'll talk about your calculator a little bit, and we'll see how this works. So let's determine the missing angles. Okay, so we've got a right triangle. Let's say that the short leg is 3 and the hypotenuse is 5. And we need to find both of the acute angles here, okay? So let's say we've got theta. Let's call that angle theta. So if I think about theta, the sides I have in relation to it are the adjacent side and the hypotenuse. So I know that I'm going to use a cosine statement for this. Cosine is cosine adjacent hypotenuse. So I know that the cosine of theta outputs adjacent over hypotenuse, 3/5. So the question is, how do I figure out what theta is? Well, since theta is an acute angle, which it will be for all the right triangles, I just look at the inverse of this. So I inverse this statement. So now my function is the cosine inverse function. The input is my ratio, and my output is my angle theta. The input and output switch places here. So this tells me precisely how to calculate theta. Now it's a calculator exercise. Okay? Now, the problem is when you type this into your calculator, it's going to give you a number that represents an angle, right? We know that angles can be degrees or radians. So it's important here that if you want your answer in degrees, you put your calculator in degree mode. Now, there may be a setup button on your calculator, there may be a mode button. Look at your manual for whatever calculator you have and make sure you're in degree mode. So if you do that in degree mode on your calculator, then cosine inverse, again, if cosine inverse is probably associated with the cosine button. If you want to use cosine inverse, you may have to hit second or shift to access the inverse part of that button. Okay, so again, that's different on every calculator. But if you type cosine inverse of 3/5 in degree mode, your answer will be not equals, but it will be approximately equal to, let's say, 53 degrees. Okay, so theta up here is approximately 53 degrees. If you're in radians mode, your calculator is going to output, let me redo this in radians mode. Your calculator will give you approximately 0.93. And if you're in radians mode, you know that that's a radians answer. Those two angle measures are equivalent or very close because we rounded, okay? So theta is 53 degrees. Let's stick with that. So that's how you use an inverse trig function. You set up the trig ratio and then importantly, you inverse it, okay? Eventually, we'll skip setting up the ratio and just work on the inverse part. But in either case, you can find the third angle by subtracting 53 degrees from 90, and that will be 37 degrees. Approximately, because the 53 was approximate. Okay? Now, how else could you find the 37 degree angle? Well, in reference, let's take a shortcut now if you want to use inverse trig, because we didn't have to find the 53 first, right? So let's say we wanted to find the 37 degree angle. In relation to the 37 degree angle, 3 is opposite and 5 is hypotenuse. So what you would do, opposite hypotenuse, you're going to look at sine. But if you want to solve for an angle, you're going to use sine inverse, and the input is going to be the ratio, opposite over hypotenuse, and the output will be your angle. Okay, so if you type that in, you should get approximately 37 degrees if you're in degree mode. Okay, so that's an introduction to the inverse trig functions here. Now let's make some generalizations. Let's make a summary here that will make this quicker for you to work with. If you look at a trig structure, just a regular trig function structure, you have your function, right, sine, cosine, tangent. The input is an angle, and the output is a ratio. Okay? If you look at the trig inverse structure, then you have your inverse function, but the ratio is now your input, and the angle is your output. Okay? So this is useful if you want to calculate an angle. Take the inverse trig function with the ratio as the input. So let's see another example. Determine theta. So we've got a right triangle. Again, this only works with right triangles. And let's say that theta is this angle, and let's assume that we have the vertical side is 4 and the horizontal side, in this case, let's say is 6. Now, just so we understand, you could find the hypotenuse using the Pythagorean theorems. That would be the square root of 16 plus 36, so that's the square root of 52. So now you have lots of options for calculating theta. We know that theta is going to be an inverse trig function of an angle, right? So you have opposite, adjacent, and hypotenuse. You could use any of the inverse trig functions. For example, if you want to calculate theta using sine inverse, you would input opposite over hypotenuse. So opposite would be 4, hypotenuse would be the square root of 52. Or you could use the cosine inverse function with adjacent over hypotenuse. Or you could use the tan inverse function with opposite over adjacent. If you type any of those three expressions into your calculator in degree mode, let's work in degree mode here, and I'm doing it right now. No matter which one of these you type, you should try all three for yourself. It looks like you'll get about 33.7 degrees. So the cool thing about this is mathematics works. You can use any of those three, whichever you like, and you'll get the same answer. Okay? Understand that it's rounded though. But the big thing to take away from this video is understanding the structure of the inverse trig functions. Of course, you should already understand the structure of the trig functions. Angle input, ratio output. Inverse trig functions simply reverse that.